welcome to this STAIR Tailored. I'm Erica Mason from the University of Missouri, and today we're going to present to you a practice to research and back to practice video in which we hear about how productive struggle and cognitively demanding tasks are related. So this is Adam Smith. He's a district administrator and he focuses on supporting elementary teachers in the area of mathematics. And he's going to talk about the experiences he's had in seeing the relationship between cognitively demanding tasks and productive struggle.
Some tasks don't even lend themselves to productive struggle because they can be low level from the outset. So the teacher has to be really mindful about the tasks that they are placing in front of their students to make sure it is eliciting, promoting the productive struggle that is intended, that is the intended outcome. So the task needs to kind of mirror what the teacher moves could be. Do they have an authentic scenario or authentic real-world experience? Are the questions open-ended? Does it require the student to go between and among context and math and modeling through representations? Does it require the student to explain? Does it require that the student either explain whether in symbols, numbers, or words, or pictures, etc.? Does it require that deeper understanding of the content? Does the task allow for authentic student interaction? Or is it just ask this of your partner and write it down, and now partner B asks this of partner A and you write down their response? Or is there a meaningful exchange of ideas? Now, if the task really is too high, then that could lead to an opposite yet similar issue where students they can't access, and there's no learning happening. And the teacher needs to be mindful of how to adjust that task as well, or how to adjust their approach to that task. And we all know Vygotsky's, ZPD, right? Zone of possible development. So the teacher has to really know their students, wholly and individually, to make sure that the task put in front of their students isn't at ZPD. Because if it's not, then we could either die of boredom or die of disengagement because I'm frustrated, die of frustration.
So as we've just heard, Adam reminds us that when we're thinking about this relationship, we first need to consider the mathematical task we're presenting and ensuring that the kind of task we give even has the opportunity for students to engage in some productive struggle. And so that's really a first consideration. He also then encourages us to remember that a worthwhile task or a cognitively demanding task is going to be one that is open-ended, right? That has multiple entry and exit points, that it can be represented in multiple ways or with multiple tools or resources, and that it really gets at students' mathematical thinking. Let's turn now to what the research says that supports what Adam just said about the importance of starting with a cognitively demanding task. So mathematics education researchers Margaret Smith and Mary Kay Stein present 4 levels of cognitive demand that help us take a mathematical task and look at its characteristics to decide what's the level of cognitive demand that's available in this task. The 4 levels are memorization, procedures without connections, procedures with connections, and doing mathematics. And so what teachers can do is they can look at a mathematical task, look at the type of thinking that's required in that task, and then they can decide, is this a low cognitive demand task or a high cognitive demand task? Based on that information, they can just move forward with either increasing the cognitive demand or making sure that they're interspersing low cognitive demand and high cognitive demand tasks. This other example from research comes from Lynch, Hunt, and Lewis, and their article is called Productive Struggle for All Differentiated Instruction. So again, they start with the premise that you would present students a cognitively demanding task, and that's really with the goal of encouraging students to engage in some productive struggle. Adam mentioned that it's important to really attend to your students, to know your students, and to make sure that that productive struggle doesn't become so challenging and arduous that then it turns unproductive and that students become frustrated. So in this article, these researchers offer us some really practical strategies for how we can start with a cognitively demanding task and then do some really intentional differentiation that's going to maintain the rigor of the task, but then make the task more accessible and usable for students. That actually brings us back to practice, right? So how does this look in your classroom? How does this look in practice? And so in that Lynch, Hunt, and Lewis article, they present this task, the Aunt Martha's cupcake task, which says Aunt Martha has 5 trays of cupcakes. She decides how they were arranged, right? So there were 100 total cupcakes, and on the first and second trays, there are 52 cupcakes. On the third and fourth trays are 43 cupcakes, and then the second and third trays have 43 cupcakes, and the third and fourth have 34 cupcakes, and finally the fourth and fifth have 30 cupcakes. So how many cupcakes are on each individual tray? And in their article, the authors describe how this is a cognitively demanding task in and of itself, and you could present this to students. But if you have other students who are going to need some more support to access this task, there are a couple practical things you can do. So first, you could change the numbers, right? You could introduce students to the very same problem, but instead of 100 total cupcakes, you could start with 20 total cupcakes, and then subsequently offer different totals for the combination of trays. If even that seems inaccessible to students, you could have students start at the most basic level of this task, which is, let's just consider that you have 10 cupcakes and 2 trays. What are all the different number combinations that are possible for the different numbers of cupcakes that could exist on each tray? So you're introducing students to the same kind of thinking that's evident in this task, but you're just making it accessible to students and in a way that's going to be useful to them. You could also ask students to sort of reason about this task backwards by saying, okay, let's say you are going to create this task and you have 20 cupcakes. How might you rewrite this problem so that you fill in all of these numbers down here? So again, students are reasoning in the very same way they would if they were solving this task, but they're just starting at it from a different place. Thanks so much for watching this STAIR Tailored video. As you move forward, consider what Adam has said with the idea of knowing your students as a mathematician, making sure they have access to cognitively demanding tasks, and then making sure that you're supporting them in their experiences with productive struggle.